Hi everyone. In this week's Scholarship Chemistry tutorial video, I'm taking up question 2A from the 2007 exam. In this question, we have a sample of steel that's been dissolved in acid, and we're trying to recover one of the metal ions that was a component of steel. We're trying to recover the iron, while ensuring that none of the nickel actually precipitates while we're trying to recover that iron. We need to calculate the pH range over which iron will precipitate in the form of iron hydroxide. So as we're going to add some hydroxide to the solution, but we're not going to add too much, or else if we add too much, we'll cause the other metal ion to precipitate as well. So we're trying to figure out that optimal range to precipitate one but not the other. The first thing we need to do though is to actually calculate the concentrations of the iron and nickel in the acid before we even begin adding any hydroxide to precipitate the nickel. So let's do that. Knowing the mass of nickel and iron, we are able to calculate the concentration. We know the mass of nickel and iron because we know 10% of the total mass is nickel and 70% of the total mass of steel is iron. Once we get the true mass, we can convert it into moles using mass divided by molar mass. We get the molar masses from the periodic table because they're not stated in the question, but we know to look it up on the table. And then we can calculate concentration using the formula C equals N over V, or moles divided by volume. And we ensure that we plug in the volume in liters, not in 200 milliliters as what was given in the question. So make sure you convert from milliliters to liters. So now we've got the concentrations of these two ions. We need to calculate the pH range over which iron will precipitate, but not nickel. So we don't want to add too much hydroxide. So we need to calculate the lower limit that iron will precipitate out, and we need to calculate the upper limit that will cause nickel to precipitate out, because that will be the max we want to go. So step one, we need to calculate the lower pH range limit. And to do that, first we need to find the hydroxide concentration that will cause iron to precipitate. And then once we know that, we can convert that hydroxide concentration to pH. In step 2, we'll calculate the upper pH range limit by finding the concentration of hydroxide that will cause nickel hydroxide to precipitate, and we'll convert that number into a pH as well. So let's do step 1. First, we're told in the question we need to make sure that no more than 0.1% remains in solution when we're precipitating the iron. In other words, the concentration of iron ions actually in the solution as we're precipitating it has to be no more than 1.25 times 10 to the negative 5 moles per liter. Pretty small number. So you have to make sure you took the concentration we just calculated for iron and multiplied it by 0.1%, because that is the concentration of iron ions that must be left in solution if we're doing this precipitation right. So knowing that concentration, we can plug it into the solubility product expression for iron hydroxide. Ks for iron hydroxide is a known value, it's a constant, so that was given to us in the question, so we plugged that in as well. And our only unknown in this equation is the concentration of hydroxide. So by rearranging, we get that concentration, and we can calculate the pH as well. The pH will be 2.78. That is the lower limit, the lowest concentration of hydroxide that will cause precipitation to occur. But we're going to keep adding hydroxide to precipitate more out, and we're going to now calculate the upper limit of hydroxide, the upper limit concentration that will cause nickel to precipitate, which we don't want. That's where we're going to stop the precipitation. So, to calculate the upper limit, we need to use the solubility product expression for nickel hydroxide. We know the concentration of nickel ions. We calculated that at the beginning of this question. And once again, we know the solubility product constant for nickel hydroxide, also given to us in the question. And our only unknown, once again, is the amount of hydroxide. We can calculate the concentration of hydroxide ions when nickel hydroxide precipitates. And with that number, we can calculate the upper limit pH, and we get 7.75. So to answer the question, the pH range that will precipitate iron hydroxide while ensuring nickel hydroxide doesn't actually precipitate will be between a pH of 2.78 and 7.75. That's this week's question. Hope the answers made sense, and we'll get on to the next problem next week.